Thank you so much. With this, now let's experience the dawn of a new age as India's indigenous technologies redefine 5G standards. Witness the power of homegrown talent combining futuristic hardware and astute software strategies. This session will be initiated by Aayush Bhatnagar, Senior Vice President, Reliance Jio. Ayush's current focus is on cutting edge software platform development, including cloud native 5G core and 5G radio technology that is designed, developed, and manufactured in India. He is also spearheading 5G advanced and early 6G research to carry forward R&D initiatives in the 5G space. Prior to this role at Geo Platforms, he was involved in the successful commercialization of homegrown IMS Vault platforms and other platforms, which are running today on the world's largest Vault network. Can we please welcome Aayush Bhatnagar, Senior Vice President, Reliance Jio, with a huge round of applause. Over to you, Aayush.
A very good morning to all of you, and I'm really happy to be part of this conference today in front of such a multidisciplinary audience. So today we will be covering some of the learnings and some of the experiences that we have gone through over the past 10 years in the design, development, and large-scale commercialization of technology that is made in India. So the whole domain that we will be covering is telecom, but there are also some sister domains that we'll cover in the process. I think the mic this is not working, the pointer. Okay. Well, this is the agenda at a glance today. So obviously, the journey that we have undertaken to make India Atmanirbhar, in the words of our Prime Minister, in technology development and also in commercialization. Then we will talk about the scale of software development and the processes that are around this entire ecosystem of development. Then we'll move around some of the best practices, which I already am very confident that you know, but we'll recap some of the practices that we follow for the commercialization of software from lab to field. And then finally, we'll go into hardware development, which is a totally different ballgame, and it requires a complete rethink of how we approach our development practices. Yes. So the journey to become self-sufficient in terms of our development and our practices, it is an ecosystem of many things coming together and many things done right. So right from the time of design to the time of creating an outcome-based development program, to testing, to learning in the field, and to feeding it back, all the learnings that we get from the field, to feed them back into our development process. So it is a whole cycle. It's not something which is a point solution that can help in a sustainable development culture. So once we start developing any new project, the most important part or the most important ingredient is to define the success criteria, that what is it that will make this project successful. And that is from where the journey starts. So this slide actually is talking about this aspect in a sense. And this entire journey of being self-sufficient, it did not happen overnight. It has been a long journey of 15 plus years that we undertook. And we started very small in 2007 when we started developing 4G technologies at a time when 4G was not even known. 4G actually started coming into force after 2010. So From 2007 to 2023, this has been the journey of creating our technology and scaling our technology to newer heights. So this is just a timeline that you see here from 2007, then creation of our labs and getting both partners and creating our own technology, integrating our own technology with partner technology, and then slowly reverse engineering and reverse integrating our technology to make it one of the best in the world. So that happened around 2016 when we started deploying our technology in a hyperscale network called Geo. And then from there, the entire journey of 5G independence, it started out. So this is what we have done in India. So we have deployed one of the largest 5G networks anywhere in the world on the latest technology and by using our own software and our own platforms. So this technology has been deployed in 8 large data centers in more than 100 mobile edge compute locations. And the entire automation and IT stack, when I say IT stack, onboarding of customers, activation of services, creation of products, charging, billing, usage, invoicing, revenue assurance, fraud management, the entire 9 yards of whatever it takes to create an IT network to operate services and products at this scale. Everything has been done in-house and deployed at a very large scale. So today we have created a network which is ahead of its time. It is built on the latest standards, and we are a network in India which is now moving towards the next generation of 5G technology using our own software. So this particular map of India that you see here, this only shows where different technology components have been deployed physically in small data centers, in mobile edge compute centers, in large data centers, and covering the length and breadth of the country. And most importantly, creating a product and deploying it in the field is not the end of the story. You need to create a culture. You need to create a culture which is not dependent on individuals, a culture that is self-sustaining, a culture that can really stand in the test of time over 5 years, 10 years, 20 years. And the culture of innovation does not die down and is not dependent on a few group of people. So that is what we strive to do at Geo, and that is what we believe we have been able to do in a sufficiently large scale. And that culture of innovation, it is incubated in what we call Geo Labs. So Geo Labs is a facility in Mumbai and in Jamnagar, 2 places. And unarguably, it is one of the largest labs in the world. In our lab, we have more than 5,000 servers. We have open playground of interoperability and integration with more than 300 ISVs, including our own products, of course. And anything and everything that you may imagine, right from devices to the cloud and everything in between, that is incubated, tested, integrated, developed, and then commercialized in the larger sense of the network. So this GeoLabs facility, it has various sub-labs, device, radio, core, IT, automation, and many more. So this building that you see is where GeoLabs is situated in our beautiful campus at Navi Mumbai. Now coming to the scale of software development, we have hundreds of projects which are running concurrently. Many of those are already in production. Many of those are on the roadmap, and they're about to hit prime time in production. Many of those are older projects that we deployed 5-7 years back, and they are already on the road to transformation. So we have different kinds of projects. And if you look at the scale of our current software development practices, we have almost everything that you will ever imagine in a software factory, right from all the DevOps tools, right from staging centers to performance test centers, from performance test centers to first office applications, and then to large-scale deployment, and then the entire loop of CI and CD, which is running across multiple data centers today. So this is the scale at which we operate. And the scale is only increasing further as we are adding new sister technologies into our scope. And these are some numbers of the software that has been deployed, the kind of scale and traffic that it is handling. We are running one of the largest telco data lakes in the world. We process more than 25 petabytes of data every day. We have one of the largest automation platforms anywhere in the world. We have 6 million radio cells being automated on a daily basis across 4G and 5G. We have deployed one of the largest cloud-native networks anywhere in the world. It says 1,200 plus pods, but the number as of today is 1,600 pods, cloud-native pods, taking live traffic of hundreds and millions of customers. So the numbers speak for themselves, and they are a reflection of the quality and not just the diversity of software development at GeoLabs. Now coming to the practices, I think this is something which all of you would be very familiar with. CI and CD, continuous integration and continuous deployment, is not an alien concept to anybody, but there are always industry-specific nuances, industry-specific customizations in the practices of software development and delivery, and telecom is no different. So in the telecom domain, there are many other constraints under which we work. There are constraints regarding backwards compatibility, not just one generation, but 3 or 4 generations back. That is because just because you deploy the latest technology, it doesn't mean that you don't have to interoperate with 4G, 3G, or 2G. So those technologies came 30 years back. So while evolving to a new architecture and to new development practices, you still need to be backwards compatible to technologies which are 30 years old. So that is one of the unique challenges that we face in telecom, and that is what we have incorporated and solved in the context of our CI and CD processes. And of course, at Geo, because we have multiple disciplines, so our development pipelines and our delivery pipelines also cooperate and converge at different points of the development lifecycle. So this is what is depicted in this particular slide. We have infrastructure DevOps. So in infrastructure, we have the cloud-native infrastructure itself, and it is also an ever-evolving infrastructure. So we started off with creating pods on Docker version 19, and now we are on Docker version 24. So the entire DevOps journey of upgrading and maintaining thousands of pods carrying live traffic version by version and creating the automation platform around that, that is under infrastructure DevOps. Then there is something called CNF, Cloud Native Function, CI and CD and DevOps. So those are the actual applications which are residing as tenants on the cloud native infrastructure. So maintaining the entire life cycle, maintaining the entire evolution of each and every component in the journey, that is the CNF DevOps part. And then, of course, the CI/CD models, the radio part also comes into the picture, because now in the telecom network, radio software is also being virtualized. So that is pure software CI and CD pipelines. So this is just a depiction of how multiple disciplines, they come together and they cooperate to deliver the end outcome. This is just an amplification of what I just said, the 3 types of DevOps pipelines. Then there are multiple tools. There are industry standard tools which are used. There are custom tools which need to be used, because not every industry standard tool will do the job for us. And that is where we have created our own platforms on top of the CI/CD tools, so that we are able to manage and maintain our pipelines and our software in a manner that works for us in the telecom industry in specifics. So that brings us to the containers, because containers are what is the smallest unit of software packaging. And there we follow a bakery model, which is depicted very deliciously like a cake here. So obviously at the base you have the base image. There could be multiple base image choices, and these are something which all of you would already know. Then on top of the base image, you have the image which is created specific to a product, specific to a component, taking care of its requirements in particular. So that is the second layer of the cake of the bakery model. And then you have the applications themselves, which are packaged as containers and which are the final container images. So a product That could be one container, that could be 5 or 7 containers taken together to create a pod or multiple pods. So this is depicted here in the bakery model. And there are many such cakes in the store, in the software store, each cake representing a different product, and each product being evolving on its own in parallel in different pipelines. So that is the bakery model. And then, of course, we have the processes for hardening of software, for testing it, for making sure that it scales and evolves at the same time. There are no breakages in between. So those are the processes, right from the automation suite that we have, our OSS and BSS IT products, cloud platforms, radio software. So software DevOps is obviously what I just talked about, the interoperability testing at the domain level. Then you have user acceptance testing that takes place in one of our GeoLabs replica environment. And from replica environment, it goes to field trials. From field trials, it goes for commercial deployment and rollout for millions of customers. So this is a kind of a delivery pipeline. And it is true not just for our software, but also partner software. Then, of course, we have multiple continuous testing and upgrade setups which run in parallel. Many of these we have now put on the cloud. When I say cloud, we are using both public cloud, and we are also using our own on-premise cloud for testing and for integration setups. So that is depicted in this particular chart. And then some of the key learnings, of course, building the culture, that has to be central. Each and every engineer of the team is aligned with our culture and our principles. Each and every engineer has the visibility to the end outcome and to the end expectations, so that everyone focuses their energy towards the end goal and do not dissipate their energy in different directions. But apart from that, we have to learn from mistakes. We call it the post-mortem attitude, but we try and avoid this as much as possible. But no matter how much you test, you will find bugs in the production environment, and you need to learn from them. You need to perform escape analysis, that how did this problem reach production? You need to learn from that, and you need to make sure it never happens again. So that needs to be there. And then, of course, looking at the code itself beyond software functions. How do I automate my testing? How do I scan my code better? How do I keep improving it? How do I catch problems earlier in the pipeline, which we popularly call as shift left in the continuous integration process? So these are some of the key learnings here. And then, of course, you have the outcomes. Your software is more reliable. The performance and functionality is more predictable in nature. There are less surprises, less sleepless nights, and there is a lot of scale. So you can actually repeat it in a predictable manner at scale. Then, of course, we are also looking at GitOps for agile operations of the future. It has its own pros and cons. GitOps, I'm sure this gathering already knows quite a lot about. So that is there. Now, coming to hardware development. So at Geo, we develop our own hardware, right from our own boards, our firmware, our drivers, our thermal design, mechanical design of those temperature-hardened radios, which are manufactured in one of our facilities and then deployed across the network. So this is a totally different ball game. This is very different from pure software and IT development. So we'll touch upon some of those aspects here. Then, of course, we have an incubation phase where we start collecting the components, we start designing our boards, we start creating the concepts of the product in 3D modeling, and those concepts actually help in freezing the specifications of the hardware product. So that is the incubation phase. Then we have the PCB design flow, where we create the high-level design of each and every board, of each and every circuit. We have the schematic design and simulations. We have the PCB layout design, and we have the prototype fabrication and systems integration testing of every board, every component, and every pin. So at the outcome of the PCB design flow, we get a prototype board, which can be taken forward. Then we have the software part, which has RTL and FPGA programming, and also the drivers. And this is the flow for FPGA design flow and the tools which come into the picture. So we start right from the design requirements to the simulation models, to the HDL code. Then we go to the RTL simulations. Then we synthesize that code in hardware as RTL register transfer language. And then we place and route different IP blocks, as they are called, in an optimal manner so that the resource consumption is taken care of. And then, of course, we do the timing analysis, which is very important, and then assembly programming, and then system level testing. So this is the entire water flow of hardware code part, the code part of hardware. Then we design the antenna, because the signal that you get on the phone, that signal is coming from the equipment on the tower. So the antenna which is on top of the tower, it has to be designed very well. So the antenna design practice is a very, very specialized area, and that is what we do very exhaustively in our labs. Then the thermal design process. This hardware is running from Thar Desert to Ladakh, from a temperature range of almost 100 degrees Celsius. So the thermal design of the product has to be immaculate. It has to work in rain, in sleet, in snow, in heat, in all conditions. So these are the thermal simulations that we carry out, board by board, component by component, and then the body is designed so that it is able to dissipate the heat which is generated. Then the mechanical design process. The product has to be sleek. It has to be very, very easy to deploy, easy to carry. It has to be light. So that is the mechanical design process that we do. The die has to be created, and hundreds and thousands of such boxes have to be manufactured on the factory floor. So that is part of the mechanical design process. And then, of course, mass manufacturing. Creating 100 prototypes and making them work is one part of the story. But creating a self-sustaining factory line, which is called design for manufacturing, that is a totally different ballgame. And for that, you need test jigs. You need on-floor factory processes. And that is what is part of the mass manufacturing process, which you see here. And so many steps are involved, 11 steps in total, which are shown on this slide. So these are some of the grabs of the actual factory line, where our radio products are manufactured at scale and then deployed in different parts of the country. And the final box build that comes out, and then it is kitted and dispatched directly to the site, to the field, where it is actually mounted. So with this, I come to the end of our presentation. We can always chat on the sidelines. Thank you very much.